Okay, so this is a continuation of the water lecture. We went through half of it in person on Tuesday, and this is like the second half of that lecture. Um, Okay, so although the atmosphere contains only 0.001% of the total water supply, it plays a critical role in redistributing water around the world. This tiny fraction of atmospheric water is constantly cycling through the hydrologic cycle, transporting moisture over vast distances before it eventually returns to the Earth's surface as precipitation. Water in the atmosphere can travel great distances, sometimes moving halfway around the world before falling as rain or snow. This movement is essential for replenishing rivers, lakes, and groundwater systems, supporting ecosystems, and sustaining human populations. Even though atmospheric water is a small component compared to oceans, glaciers, and groundwater, it is one of the most important mechanisms for global water distribution. Without this process, many regions would experience droughts and ecosystems would struggle to sustain life. The majority of freshwater use, about 70%, goes to agriculture, supporting food production worldwide. Industry follows, using approximately 20%, while residential use makes up about 10% of total consumption. A key challenge is that much of our water use is consumptive, meaning it is withdrawn from the aquifer or surface waters and not returned. So irrigation is a primary example of this, where water is absorbed by crops or lost through evaporation. In contrast, non-consumptive water use, such as hydroelectric dams, does not remove water permanently, but instead temporarily diverts it before returning it to its source. So water is a critical resource, but its overuse can have severe consequences. So excessive water withdrawals, particularly from surface waters like rivers and lakes, have led to many major rivers running dry before they ever reach the sea. Some of the most well-known examples include the Colorado River in the southwestern United States, the Rio Grande, which forms part of the US Mexico border, and China's Yellow River, one of the world's longest rivers. So, when rivers dry up before reaching their natural endpoint, it has devastating ecological impacts. Wetlands shrink, fish populations decline, and entire ecosystems collapse due to lack of freshwater inflows. So, in many regions around the world, water mining is becoming a serious issue. Water mining occurs when water is withdrawn faster than it can be replenished, a process that can lead to dried up rivers, depleted aquifers, and severe water shortages for communities and ecosystems. Looking at the map, we can see areas marked in red, yellow, and orange, indicating regions experiencing um, high, moderate, and low um, water use. Some of the most affected areas include the western United States, including California and the Great Plains, parts of South America, particularly Argentina and Brazil, northern Africa and the Middle East, where water scarcity is a major concern, and large sections of Asia, including northern China and India. These regions rely heavily on groundwater and surface water sources that are being overdrawn at unsustainable rates. So, without changes in water management and conservation, many of these areas will face severe water crises in the future. So, along with surface water overuse, groundwater can also be depleted, often at an even faster rate. Groundwater depletion occurs because it recharges much more slowly than surface water. So once an aquifer is drained, it can take decades or even centuries to refill naturally. So looking at this map, we can see that several regions in the United States are experiencing significant groundwater depletion, especially in the Central Plains, particularly in Nebraska and Kansas, where groundwater is heavily used for agriculture. Also in the Southwest, including parts of California, Arizona, and Texas, where arid climates make groundwater an essential resource. And lastly, the Southeast, where expanding populations and industrial use contribute to high water demand. So as aquifers are mined, water tables drop, making it harder and more expensive to access water. And this can lead to land subsidence, reduce water availability, and increase competition for remaining resources. So as we continue discussing groundwater depletion, let's take a look at this case study in Texas where landowners are actively drilling new freshwater wells and selling the water to fracking companies. So hydraulic fracturing or fracking requires millions of gallons of water per well. So this water is mixed with chemicals and injected underground at high pressures to extract oil and natural gases. While this process has boosted energy production, it also intensifies groundwater depletion, especially in regions already facing water scarcity. So unlike water use for irrigation or household needs, fracking water is often not returned to the water cycle. It becomes contaminated and is typically disposed of in deep injection wells. The sign in this image highlights how groundwater is now being treated as a commodity, with landowners profiting from selling it to industry. But this raises an important question. How do we balance economic benefits with long-term water sustainability? So in addition to groundwater depletion from overuse, another major concern is saltwater intrusion in coastal areas. Under normal conditions, fresh groundwater naturally flows towards the ocean, creating a pressure barrier that prevents salt water from moving inland. However, when we over extract groundwater, this balance is disrupted. As a result, salt water moves into inland aquifers, contaminating them with saline water. This is already happening in coastal regions of California, Florida, India, and the Middle East, where wells are now drawing up salty water instead of fresh water. Once this occurs, the water is often unsuitable for drinking or irrigation without expensive desalination treatments. This issue highlights the need for sustainable groundwater management to protect our freshwater resources and prevent long-term damage to coastal aquifers. So as we continue to extract groundwater, we don't just risk running out of water, we also destabilize the land. When water is pumped out of an aquifer, the spaces that once held water collapse, causing the land above to sink or subside. This process is called land subsidence. In extreme cases, this can lead to sinkholes like the one shown in this image. As the ground loses support, it can suddenly cave in, swallowing roads, buildings, and infrastructures. Florida, Texas, and California, and many other areas that rely heavily on groundwater have seen an increase of subsidence and sinkhole formation. This not only damages property, but also makes future groundwater storage more difficult, as the compacted ground can no longer hold as much water. So this highlights the importance of groundwater conservation, not just to preserve water supplies, but also to prevent serious geologic hazards. So now that we've looked at land subsidence and um, sinkholes, let's look at how sinkholes develop over time. So first, it all starts with rainwater, which naturally absorbs carbon dioxide from the air and soil, making it slightly acidic. As the water seeps into the ground, it slowly dissolves carbonate bedrock, such as limestone, creating underground voids. Over time, these underground cavities grow larger as more soil and rock from above collapse into them and are washed away by groundwater flow. As the void expands, the roof of the cavity becomes unstable and begins moving upward, weakening the ground above. Eventually, the structural integrity of this surface is breached and a sinkhole forms, often suddenly without any warning. This can cause major damage to buildings, roads, and even entire communities. Sinkholes are common in regions with limestone bedrock such as Florida, Texas, and parts of the Midwest in the U.S., as well as other karst landscapes around the world. So now we can talk about another use of groundwater, which would be bottled water. So bottled water has become a booming industry with global sales reaching $160 billion in 2015. People often buy bottled water for convenience and perceived better taste, but studies including blind taste tests have shown that people cannot consistently distinguish between bottled or tap water. However, bottled water comes at a major environmental cost. Producing bottled water requires 1,000 to 2,000 times more energy than simply using tap water. Additionally, the industry generates 1.5 million tons of plastic waste every year, much of which ends up in landfills or pollutes our oceans. This raises important questions. Is the convenience of the bottled water worth the ecological cost? What role do companies play in groundwater depletion by extracting and selling it as bottled water? So flooding is a natural process that occurs when snowmelt and heavy rainfall increases the volume of water in a river, causing it to overflow its banks. Floods have both positive and negative impacts. Ecologically, floods can be beneficial in the long term. They spread nutrient-rich sediments across large areas, improving soil fertility and supporting wetland ecosystems. However, in the short term, floods can be destructive, especially for people living in floodplains. They can damage property, displace communities, and even lead to loss of life. To mitigate risk, humans have engineered levees, which are embankments built along riverbanks to contain floodwaters and keep them within the main channel. So while levees provide protection, they can also have unintended consequences. Throughout history, humans have found ways to move water from one place to another to meet our needs. One of the most significant ways we do this is through aqueducts. Aqueducts are engineered channels that transport water from distant sources to cities and agricultural areas. A key example is the Colorado River Aqueduct, which diverts water from the Parker Dam and carries it hundreds of miles to supply Los Angeles and San Diego. These systems are essential for supporting large populations and food production in arid regions. However, they also raise concerns about water overuse, ecosystem disruption, and conflict over water rights. The diversion of surface water has had both positive and negative impacts on different regions. On one hand, aqueducts have transformed areas like California's Central Valley into some of the most agriculturally productive regions in the world. This region alone produces over a third of the vegetables and two-thirds of fruits and nuts consumed in the United States. However, this water diversion comes at a cost. The movement of large amounts of water to support agriculture in some areas has dried up rivers, lakes, and wetlands in others. For example, the diversion of the Colorado River has significantly reduced water flow to the Colorado River Delta in Mexico, leading to the loss of wetlands and biodiversity. Clean fresh water is essential for nearly every human endeavor. Water can be recycled if its quality isn't degraded by use. Water withdrawal is the total amount of water taken from a water body. Much of this water can be returned into circulation be returned to circulation in a reusable form. Water consumption, on the other hand, is loss of water due to evaporation, absorption, or contamination. Worldwide, agriculture claims about 70% of total water withdrawal, and that use is increasing rapidly worldwide. Most of us never think about the water required to grow and prepare the food we eat. Raising a kilogram of beef in a concentrated feeding operation, for example, takes more than 15,000 liters of water because cattle in these facilities are fed grain, which they process very inefficiently. That often was grown with water-intensive irrigation systems. The result is that the average hamburger takes 2,400 liters or 630 gallons to produce. Raising goats requires at least 90% less water from all sources than cattle because they eat a much wider diet and metabolized what they do eat more effectively. So rice cultivation, which generally occurs in wet paddies, takes about 3 times as much water as raising potatoes or wheat. So this graph illustrated the water required to produce 1 kilogram of some important foods. Um, yeah. Plant-based foods like corn and potatoes and wheat require relatively little water to produce, whereas animal-based foods require significantly more. So rice and soy require more water than most other crops, but still less than meat production. Among meat, chicken and pork are more water efficient than beef, which is one of the most water intensive foods. One surprising fact from this data is that chocolate has an even higher water footprint than beef, producing just 1 pound of chocolate requires over 2,000 gallons of water. Um, industry use Industry uses represent about 1/4 of all water withdrawals worldwide. Some European countries use 70% of water for industry. Less industrialized countries use as little as 5%. Cooling water for power plants is by far the largest single industrial use of water, typically accounting for 50 to 75% of industrial withdrawal. If treated properly, much of the cooling water can be recycled for other uses. A rapidly growing demand for water is for biofuel production. It currently takes 4 to 5 liters of water to produce 1 liter of ethanol. Water scarcity may limit our biofuel use. Domestic or household water use accounts for about 6% of world water use. This includes water for drinking, cooking, and washing. The amount of water used per household varies enormously, however, depending on a country's wealth. The United Nations reports that people in developed countries consume on average about 10 times more water daily than those in developing nations. Poorer countries often can't afford the infrastructure to obtain and deliver water to citizens. There's vicious cycle between water stress and poverty. Each contributes to the other. Freshwater shortages are one of the most pressing global challenges today. Access to clean drinking water and sanitation is essential to prevent communicable diseases and maintain public health. Yet, one out of every 5 child deaths under the age of 5 is due to water-related disease. The United Nations estimates that over a billion people lack access to safe drinking water, while 2.5 billion do not have adequate sanitation. As populations grow, more people migrate to urban areas, increasing demand for water, for agriculture and industry. This growing demand is leading to scarcity and worsening water shortages in many parts of the world. So as we've seen, freshwater shortages are a growing problem, but these issues are not evenly distributed across the globe. Most people currently facing water scarcity live in Asia and Africa. These regions experience high water stress due to low rainfall, high demand, and limited infrastructure. The biggest challenges occur in Africa and Asia, where rainfall is low and poor countries struggle to adapt to the increasing demand for water. The map highlights regions where freshwater availability is critically low, leading to vulnerability, stress, and scarcity. Without urgent action, water insecurity will continue to impact millions, affecting health, agriculture, and economic stability. More than two-thirds of the world's households have to fetch water from outside of the home. This is heavy work, done mainly by women and children, and sometimes taking several hours a day. Improved public systems bring many benefits to these poor families. So groundwater is a critical resource, providing nearly 40% of fresh water for agriculture and domestic use in the United States. However, in many areas, groundwater is being withdrawn faster than it can naturally recharge, leading to depletion of aquifers. One major consequence of excess groundwater withdrawal is land subsidence, where the ground surface sinks due to the collapse of depleted aquifers. Another serious issue is saltwater intrusion. As fresh water is removed, salt water from nearby oceans can seep in, contaminating drinking water supplies. If groundwater depletion continues at this rate, water shortages and land instability will become even more severe. So to better understand groundwater depletion, we need to first look at how aquifers function. Aquifers are groundwater layers of permeable rock or sediment that store and transmit groundwater. They are recharged when precipitation infiltrates the ground and replenishes underground water supplies. So there are two main types of aquifers. The first being unconfined aquifers. These are closer to the surface and more susceptible to contamination and depletion. And then we have confined aquifers. These are deeper and protected by impermeable rock layers, but they take much longer to recharge. So groundwater moves through aquifers from recharge areas where water enters to discharge areas where it flows out naturally, such as rivers, lakes, and springs. When we overpump aquifers faster than they can be replenished, we lower the water table, reducing the flow to discharge areas and potentially causing land subsidence or saltwater intrusion. Florida's water supply depends heavily on underground aquifers, particularly the Floridan aquifer system, one of the most productive aquifers in the world. So first, the structure of Florida's aquifers. The Floridan aquifer is a vast limestone-based aquifer system beneath the southeastern U.S., providing water for millions of people. It consists of superficial upper and lower aquifers separated by semi-confining layers that affect water flow. Recharge occurs from rainwater infiltration, but over-extraction can lower water tables and reduce natural springs. And then we have water conductivity and quality. So the map on the left shows specific conductance in wells across Florida. Higher values, or the red dots, indicate increased salinity, often from saltwater intrusion, which is a major issue in coastal regions. And then two, overpumping groundwater near the coast pulls saltwater inland, contaminating freshwater supplies. And then we have groundwater use and impact. So the cross section on the right illustrates how groundwater moves through the system, supporting wells, springs, lakes, and rivers. Excessive groundwater withdrawal can contribute to sinkhole formations, as seen in parts of Florida, where collapsing limestone creates hazardous ground conditions. So managing Florida's aquifers sustainably is critical to ensuring long-term water security for agriculture, industry, and urban populations. The disappearance of the Aral Sea, a human-made environmental disaster. So for nearly 40 years, the Aral Sea has been shrinking at an alarming rate. So once the fourth largest lake in the world, it has now lost more than 90% of its volume due to massive water diversion projects. So what has happened? Rivers that once fed the Aral Sea now diverge for irrigation to support cotton and rice farming in Central Asia. With no replenishment, the sea has rapidly evaporated, leaving behind vast salt flats and desert-like conditions. So what are the environmental consequences? The exposed lake bed has turned into a source of toxic dust storms as pesticides and salt residue from the former seabed are carried by the wind. The changing climate in the region has made summers hotter and winters colder, disrupting local ecosystems and agriculture. The fishing industry collapsed, destroying the livelihoods of communities that once depended on the sea. And then what's the lesson in water management? So the ROC disaster is a stark reminder of the consequences of unsustainable water use. Efforts have been made to partially restore the northern portion of the sea, but the majority of the damage is irreversible. Many environmental scientists have warned that water shortages can lead to wars between nations. Fortune magazine wrote, "Water will be to the 21st century what oil was to the 20th." With one third of all humans living in areas with water stress now, the situation could become much worse as population growth and climate change dries up some areas and brings more severe storms to others. Already we've seen skirmishes, if not outright warfare, over insufficient water. In Kenya, for instance, nomadic tribes have fought over dwindling water and grazing. An underlying cause of genocide now occurring in Darfur region of Sudan is water scarcity. When rain was plentiful, Arab pastoralists and African farmers coexisted peacefully. Drought, perhaps caused by global warming, has upset that truce. The hundreds of thousands who have fled to Chad could be considered climate refugees, as well as war victims. Although they haven't usually risen to the level of war, there have been at least 37 military confrontations in the past 50 years in which water has been at least one of the motivating factors. We could probably save as much as half of the water we now use for domestic purposes without great sacrifice or serious changes in our lifestyles. Simple steps such as taking shorter showers, fixing leaks, and washing cars, dishes, and clothes as efficiently as possible can go a long way towards forestalling the water shortages that many authorities predict. Isn't it better to adapt to more conservative uses now when we have a choice than to be forced to do it by scarcity in the future? Water conservation appliances such as low volume shower heads and efficient dishwashers can reduce water consumption greatly. So toilets are our greatest domestic water user. Usually each flush uses several gallons of water to dispose of a few ounces of waste. On average, each person in the United States uses 50,000 liters or 13,000 gallons of drinking quality water annually. Uh, to flush toilets. Low flush toilets can drastically reduce this water use. Gray water or recycled from other uses, water that's recycled from other uses, could be used for flushing, but installing separate pumping systems is expensive. So, saving water and preventing pollution. Each of us can conserve much of the water we use and avoid water pollution in many simple ways. Don't let the faucet run while brushing your teeth or washing dishes. Draw a basin of water for washing and another for rinsing dishes. Don't run the dishwasher when it's half full. Fixing leaks, okay. Fixing leaking faucets, tubs, and toilets. A leaky toilet can waste 50 gallons per day. To check your toilet, add a few drops of dark food coloring to the tank and wait 15 minutes. If the tank is leaking, the water in the bowl will change colors. Dispose of used motor oil, household hazardous waste, batteries, and so on responsibly. Do not dump anything down a storm sewer that you wouldn't want to drink. Avoid using toxic or hazardous chemicals for simple cleaning or plumbing jobs, and plunger or plumber snakes will often unclog a drain just as well as a caustic acid or lye. Hot water and soap can accomplish most cleaning tasks. So I think some other ones that we didn't say were that if you have a lawn, use water, fertilizer, and pesticides sparingly. Plant native, low maintenance plants that have low water needs, and if possible, use recycled gray water for lawns, house plants, and car washing. So for our conclusion, as we've seen through this presentation, water is a finite and precious resource. However, the increasing demand of a growing human population combined with the effects of climate change on rainfall patterns means that water scarcity will become an even bigger challenge in the future. So why does water matter more than ever? As we continue to withdraw groundwater and divert surface water, ecosystems are suffering, leading to desertification, land subsidence, and saltwater intrusion. Agriculture, industry, and urban development will compete for increasingly uh, limited water supplies. So the rising risk of water conflicts. Transboundary water disputes are becoming more common as countries struggle to share water resources. So ensuring sustainable water management policies and international cooperation will be critical to preventing conflicts and ensuring global water security. And then last, what is the path forward? So investing in water conservation technology, sustainable agriculture, and better water governance will be essential. Every individual has a role to play in reducing water waste and advocating for policies that protect our water supply for future generations. So water is not just a resource, it's the foundation of life. How we manage it today will determine the future of our planet and its people.